figures. Significant figures have to do with lab measurements. So that's really important to remember. So significant figures are all of the digits that are read off of an instrument scale plus an estimated digit. The last one is an estimate. Your estimation builds in uncertainty. So one person might have, oh, that's 2.55. And somebody else might say, oh, that's 2.53. And they're both considered right because that last one is an estimate. The more significant figures, or as abbreviated sig figs, the more accurate the instrument. So, for example, if you have a ruler to measure length versus a bamboo stick to measure length, this would be more accurate, the ruler, because it has more graduations, more lines that make it accurate. You can tell that it is more accurate because it has all those lines versus a bamboo stick. There are rules to looking at numbers and then determining how many sig figs there are. So the first rule is if the measurement is greater than 1 and contains a decimal place, all of the digits written are significant, including all zeros. So here are some numbers. Indicate all of the significant digits in the measurements below. So let's take a look at the first number, 110.0. So right away I know it's a number larger than 1 and it contains a decimal place, which means 1, 2, 3, 4. There are 4 significant figures in this number. The next one is also a number larger than 1 and it contains a decimal place. So 1, 2, 3, 4, 5. There are 5 sig figs here. Again, we follow the same rule. 1, 2, 3, 4 sig figs, and 1, 2, 3, 4 sig figs here. Notice that if I had instead 21.3, that would only be 3 sig figs. So if I have a 0 here, that means the measurement tool used to come up with this answer would be more accurate than this one because there's only 1 decimal place versus 2. All right, so bear with me here. Oh, that is bad. Do you know what that is? That's supposed to be the United States. This is supposed to be the Pacific Ocean. This is the Atlantic Ocean. Why did I just desecrate our country? Well, to help you remember the next rule. This has to do with the decimal place. If the decimal place is present or absent. Okay, here we go. If the measurement is greater than 1, but this time there's no decimal place, we're going to start at the end of the number and move right to left. So see how there's no decimal place? It's absent. We're going to move right to left. Absent to present. Okay? The first non-zero digit and all digits to the left is significant. Now I know that seems really hard to digest right now. So let's take a look. Let's see if maybe looking at some numbers will help. Okay, our first number is larger than 1, but it doesn't have a decimal place. So where would the decimal place be if we had one? Well, it would be here. Okay? So I'm going to move from right to left. So here, our first digit is a 0. That doesn't count. That is not significant. So I move on. This 1 is significant because it is non-zero. So that and anything else to the left counts. So 1, 2 sig figs. Okay? Next number. Start where the decimal place would be. I'm going to move from right to left. Skip this. This is non-zero. Count it and everything else to the left. 1, 2, 3. Now notice that this 0 is considered significant. That's because it's sandwiched between some non-zeros. So that means it's counting. Okay, the next one. Decimal place is absent, and it is above 1. So I'm going to start here with this 9. Well, my first digit is non-zero, which means I count it and everything else to the left. So that's 1, 2, 3, 4 sig figs. Last number, bigger than 1, no decimal place, which means I move from right to left. But these are all non-zero, so 3 sig figs. So if your decimal place is absent, you move from right to left. Okay? Now, here we go. Oh no, sorry, America. That's even worse. I don't know what's going up here in New England. So this time, what if we have a number where there is a decimal place that is present? Okay? If a measurement is less than 1, which means if it's less than 1, it's 0 point something, which means obviously we have a decimal place. Start at the decimal place, and this time we're moving left to right, present to absent. The first non-zero digit and all digits to the right are significant. So here are some numbers. The first number, you notice it is less than 1, so obviously it has a decimal place. So we start here at the decimal place, and we move this time to the right. First number, 0, doesn't count. Next number, 0, doesn't count. This number, that is non-zero, so anything to the right counts. 1, 2, 3 sig figs. None of these zeros count, but you must, of course, include them in your number because otherwise it would be 120, and this is 0.00120. Okay, again, we have a number less than 1. It has a decimal place, so we start at the decimal, move to the right. The first digit, that's non-zero, so I count it and everything else to the right. 1, 2, 3, 4. Which means, even though these zeros are written, and you might say, well, isn't 0.1 equal to 0.1000? Yes, mathematically it is, but we're talking about measurement scales. We're taking a measurement, and if you are able to say that there are zeros in these 3 decimal places, that is a much more accurate measurement than just 0.1. So there are 4 sig figs there. Third one, we have a number less than 1, so we have a decimal place. We're going to start at the decimal, move to the right. 1, that's non-zero, so all of those count. 4 sig figs. Finally, the last one, what do you think? Less than 1, skip, count them all. Now notice again, there's a 0 right here, sandwiched in. It is significant because it's between non-zeros. If you think about our measurement tools, all of your measurements are made by taking it 1 digit beyond the smallest. And so it's important to say that the last digit is an estimate. Now, your rule of thumb should not be memorized. Your rule of thumb should be, let's always look at the scale. But I'm going to tell you, in our experience, this is what's going to happen. So remember what this is called? This is called a quad beam balance. And maybe we've already talked about this in class, but a quad beam balance has 3 decimal places in its final values, which is the thousands place. So when you take a measurement off a quad beam balance, you would have something with 3 decimal places. And of course, that's in grams. The quad beam is more accurate than this, which is called the triple beam. They're both, very decent balances, but the quad beam is what we use more often in chemistry. So the triple beam can only go to 2 decimal places, and you don't have to take my word for it. You could look at it and you could see it yourself. That's to the hundreds place. So you would have something that goes out 2 decimal places, and it would be measured in grams. And this last number could be different between you and your lab partner or somebody, doing the lab across the hall, because that's up to interpretation. Metric ruler. If we're working in centimeters, So centimeters is going to have 2 decimal places. This picture does not really do it justice. If we were dealing with thermometers, most thermometers go to the tenths place, 1 decimal place. So again, something like this, cm, blah, blah, blah. Now, grad cylinders, I cannot make any generalization. So no generalization. Sorry, my cursive is pretty messy. The reason why is the scale on graduated cylinders varies a lot. So depending on the size of the grad cylinder, you could be going up by 1s, you could be going up by tenths, you can be going up by 2/10. So there's really no way to generalize. So you're just going to have to look at the scales. Okay? Indicate the proper number of sig figs. Okay, so here is where I try for the 3rd time to do it right. That's awful. Anyways, the first thing I want to do is look for numbers that are greater than 1 with a decimal place, because everything's going to count. Greater than 1 with a decimal place. This one. Yes, I noticed that there's nothing in the tenths place, but it does contain a decimal, and the reason why is to indicate 4 sig figs. Okay? Are there any numbers that are bigger than 1 that do not have a decimal place? So we're going to move from absent to present. So this first one, this way, 2 sig figs. This one, we're going to move to the left, 4 sig figs. That third one is not. The fourth one is not. The fifth one, yes. So skip, 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 counts it, 1 sig fig. Notice the difference between this and this, because that decimal place at the end makes all those zeros significant. Skip, those count, 2 sig figs. All 4 count. Oh, this counts all of them. So 3, 6, 7, 8. 3 sig figs and, oops, tricked me, 1 sig fig. Finally, you go the opposite way if you have a number less than 1. So this first one is non-zero, so we count all 3. Skip, skip, count them both. Skip, 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 count it, 1 sig fig. Okay? Our next rule has to do with scientific notation, so we're going to stop there. Okay, thanks.